Hello, good morning class. Welcome back from this short break of just 2 days that is a normal weekend. Today we are going to have what you have seen on the board. Though we discussed this like this, but this is actually different with what we discussed earlier. So today's class should be a resistivity, conductivity, fields and its types, electric field, and finally an assignment. So students are now on to resistivity. Resistivity by definition is just the ability of a substance to resist the flow of electric current through a conductor. Every conductor has its own resistivity, depending on the nature, the type of the material used to make the conductor. So resistivity is just a property of a substance that can give it a chance to resist the flow of electric current through it. Take an example: a copper, a silver, a zinc, aluminium. All of them are metals. They can serve to be a conductor. They can serve to be, or they are all conductors, but they have different abilities to resist electric current. Like in this case of what I said just now, among the metals I just mentioned, silver is the best conductor. That means it is a poor resistance. It has a poor resistivity. It resists very small current. That is the reason why it becomes a very good conductor. It generates electricity more of course than other metals. Take an example, a copper again. A copper can conduct electricity below the silver. Why? Because it has a high resistance. Among the one I mentioned, zinc has a very poor conductor, or it is a conductor definitely, but it conducts electric current very light or very small compared to the rest of the metals I just mentioned. Why? Because it has a high resistivity. So resistivity and conductivity, they are inversely proportional. The higher the resistivity, the lower the current it gives out, while the higher the conductivity, the very low the resistivity a metal possesses. Don't confuse when I say a conductor. A conductor is anything that can conduct, that can allow electric current to pass through it. The zinc I mentioned, the aluminium I mentioned, the copper and the silver, all of them are metals, and they are also called conductors. So their resistivity give us a chance to make a possible choice on the type of metal we are going to use to make our conductors. Mostly we use copper. Why? Because it is somehow cheaper and conducts electricity more of course than the rest, and it has a very low resistivity. Advisably, we are advised to use a conductor that has a very low resistivity to conduct our electricity to our homes. If you really need a very good electricity in your homes, definitely you need to use a very low resistivity or a very low resistance conductors. A very low resistance conductors is just copper and silver. Copper is cost, but is cheaper compared to silver. Silver is more costly than copper. Developed countries use silver to make their high tension wires than copper. Why? Because a silver is durable and it has a very low resistivity with a high conductivity. But Nigeria here, we use aluminium instead of even the copper and the silver. Aluminium can conduct electricity, but it's easily to get damaged. That's why we have electrical trippings everywhere. We have electric shortage of electricity in Nigeria across the states because we don't afford to use silver as our main conductive material. But copper is still used also. We have copper in so many states, but not in the high tension and in the distribution point. Where we usually have copper is in the home transmissions. A hung wiring made up of copper wires to some extent, but that is negligible compared to how we need it. We need copper wire even in the high tension, and we also need a silver wire even in the high tension. Why we are making this choice is because of the resistivity. We always consider resistivity when we are making choice of the conductors we use to connect our electricities. There are effects of resistivity, but before coming to the effect of resistivity, let's see the relationship, the formula for resistivity where somebody can use to make any calculations on the resistivity. The resistivity has a symbol, this. This symbol is for resistivity and it is called a rho. A rho. And this rho is a Greek alphabet, stands to be the symbol of resistivity, and the name of this symbol is called a rho. And the formula for resistivity is this: A R over L, where the R is the resistance of the conductor. Resistance of the conductor. A is the cross-sectional area. Cross-sectional area. Cross-sectional area. Area of the conductor. And L is the length of the conductor. So this is what we have as the formula for resistivity. A stands at the area, that is the cross-sectional area of the conductor. R stands at the internal resistance of the conductor, that is the builded resistance of the conductor, while L is the length of the conductor. Assuming you have a wire here, this is an electric wire. Assuming this is an electric wire, it is thicker as this. You understand? This is the thickness of the wire. So it has an area, and the area it occupies is a cross-sectional, which is this one from here to here. This is the diameter, and the area will now be A, equals to, since it is circular in nature, it should be pi r squared. This r is the radius. If distance from here to here is diameter d, therefore this r will be equals to diameter divided by 2. So to some extent, the area will be equals to pi d over 2 squared. So you either use this one or you should use this one, depending on what you are given. But actually, the area will always be pi r squared. And this pi is 3.142 or 22 over 7. Then the r depending on the thickness of the wire. Once there is a conductor, there is an internal resistance built the conductor with, which is the R, depending on how the nature of the material. Like I said earlier, copper, silver, zinc, and other metals have their own personal resistance within them. The higher conductivity, the lower the resistance, and the lower the conductivity, the higher the resistance. That is it. While this length is the length of the conductor, that is from here to here. If the copper or if the wire is longer than this, then the L will also be longer depending on what you're given. So this is what is called a resistivity. So the formula is this always. The formula is this. Don't forget. Students, I'm advising you to memorize every given expressions given to you. Every given expressions. Whenever a formula given to you, please, it's meant for you and you have to swallow it. You have to understand that very formula so that you can make use of it. If you have chance to put it in your head, please try that. It's very, very important. So this is it. Let's see how we can give out an example under resistivity. Alright, like I said, we have an example to solve under the resistivity, which says a conductor of length 200 centimeters with a diameter of 2 meters conducts electricity to some extent. Full stop. Calculate the resistivity of the conductor when it has a resistance of 100 ohms. Like I said, whenever you want to solve a problem, write solution. After writing solution, follow and break out the data. A conductor of length 200 centimeters, that is L, equals to 200 centimeters. But mind you, I said we don't calculate in centimeters, we always calculate in meters. So whatever you have divided by 100. So when you divide this by 100, you are going to have only 2 meters. That is the length. With a diameter of 2 meters, that is D equals to 2 meters. Since the formula involves area and the area involves radius, we are to get the radius R equals to diameter divided by 2, which gives you 2 divided by 2, which gives you 1 meter, which gives you just 1 meter. After this, after the diameter, the set calculates the resistivity of the conductor when it has a resistance of 100 ohms. Then the resistance equals to 100 ohms. Now after having this, we have the formula, and the formula is this, equals to AR over R. And this our A equals to pi R squared. This is equals to 3.142 times 1 squared. And this is equals to 3.142 meter squared. That is the area. So now substitute the area into the solution by saying resistivity equals to, the area is 3.142 times, my resistance is 100, which is 100 here, then divided by L, and the L is just 2 meters. So what we have now is 3.142 times 100 is the same thing as 314.2 divided by 2, and this is equals to 2 here, 1, 2 here, we have 1, remember 1, 2 into 11, 5, remember 1, 2 into 14, 7.1. So what we have as the final, the resistivity rho equals to 157.1. What remains is the unit. How can we get the unit? The unit of area is meter square. The unit of resistance is ohms. And the unit of length is also another meter. So automatically 1 meter cancel 1 meter, remain 1 meter. So automatically the resistivity becomes 157.1 meter ohms. So that is the resistivity of the material.